All right, so like there's this very old tradition at SwiftConf where I always need some kind of French guy to be speaking. And so if I remember correctly this year, I asked Franck if he had somebody in his mind. Because he knows basically everybody working in the Cocoa community in Paris because he has been doing Cocoa for the last 45 years. Since 1969! And so he told me, yeah, there's this Greg guy. And so let's see what this Greg guy has to show us. So
Sure. Hello. So my name is Greg. I'm the iOS lead dev at Kawet. And today I will present you this new architectural pattern called MVC-RS. The RS letters are often used in the car industry to refer to the most powerful cars, such as this Clio RS or this Megane RS. But I have to be honest, when it comes to cars, German people do it way better.
that's a good start.
With this gorgeous Audi RS6 or this little Porsche GT3 RS. So for MVCRS, it's a bit the same idea. It's MVC, but way more powerful. Before diving into details of MVCRS, let's have a look at the old vanilla MVC. MVC is an architectural pattern that was introduced alongside Smalltalk in the 70s to answer at the time the growing need for GUI apps. What was special with this old version of MVC is that at that time, the view layer and the model layer knew each other. The new version of MVC, the one recommended by Apple to build apps nowadays, is slightly different in the way that now the view layer and the model layer no longer knows each other. So we have the controller that knows both the view and the model. We have the view who knows no one. We have the model who knows no one. Of course, both the view and the model has to give back information to the controller. And they do this using weakly coupled tools, such as the NS Notification Center, for example, for the model, or the old target action pattern for the view. What is interesting with this new version of MVC is that now we have both those layers, the view and the model, completely decoupled. So we can reuse them. But what does it mean to reuse a layer? In fact, what does it mean to reuse some code? For Swift, it means that we will be able to reuse the code on all the platforms where Swift is available. So of course, all of the Apple platforms, macOS, iOS, tvOS, and watchOS, but also on Linux, which is really interesting because it opens a whole new world of possibilities from the smallest IoT device to the biggest mainframe servers. And there is, we saw that previously also, some work in progress on other platforms such as Windows or Android. So we can reuse our Swift code on lots of platforms, but when it comes to the view, it's slightly different. Because the view is more tightly coupled on the platform it's running on. That makes sense. You don't render the same kind of UI and you don't allow the same kind of user interaction on a watch, on a phone, on a tablet, on a computer, or on a TV. So if you've written some view code using AppKit, for example, you will be able to reuse it only where AppKit is available, so on macOS. What about the model? The model doesn't have such a constraint. So we should be able to reuse our model on almost all the platforms. But before seeing that, let's have an example of a model. This is a model that was written this year during Google I/O. So I was pretty happy to see some Swift code at Google I/O, but I'm not really happy with those few lines. First of all, obviously we are in a model, so why use a class and not a struct? If we want to use a class, why make it inherit from an S-object? Why not mark it as final? If we take a look at the parameters, obviously the author URL and post URL parameters are some URLs. Why using a string? And this last parameter, timestamp as an int, I think the last time I saw that was in a MySQL database in the last century. So, but amongst those little code smells, the thing I hate the most here is the first line. Why the hell would you want to import UIKit here? We are not even using a UIKit class. So I've rewritten slightly that model like this. We are now using a struct instead of a class. We have constant instead of variable for immutability. We are using proper types, URL, date. And I have added this last property, avatar, which is a UI image. So this time you will tell me, oh, this is fine. You are importing UIKit because you are using a UIKit class. Nope, it's not. If we want an image in our model, there is lots of other ways to do so. We could, for example, have used some data, and that property will store the PNG compressed or the JPEG compressed version of your image. Like this, we don't have to import UIKit, and this model, for example, can be reused on Linux. The previous one couldn't be reused on Linux because of UIKit, of course. It would also be more efficient from a memory point of view, because UI image wraps the whole raw data of your image, which is 5 to 10 times bigger than the JPEG or PNG compressed version. We could also have written something like this. If all the avatar were present in our bundle, for example, we could simply have used a string, and then to convert that string in the controller into a UI image, we would have called the UI image named initializer. Or, last possibility, if that avatar was a distant image, we could have used a URL. So in fact, there is lots of ways to avoid using UIKit in your model, and we should follow this rule, no UIKit classes in the model. If we follow this rule, all of a sudden, our model layer doesn't have any kind of constraints, such as running where the UI framework is available. So we should be able to reuse our model layer on all the platforms where Swift is available. Not really, because what does the model layer do? It modelizes a domain. That's what we've just seen with this post example, which obviously was taken from any kind of social network app. But the model layer is also responsible for the communication with your persistence. Here you might tell me, oh, but I'm doing the communication with the persistence in the controller. In that case, I would answer just that, and I will move on. So what is your persistence? Your persistence might be a local file, a local database, or any kind of distant call, such as web service or a REST API. If you're working with a local database, you might be using this database provider A, that provides a database that is available on all the platforms where Swift is available. In this case, it's great. You will be able to reuse your model layer on all the platforms where Swift is available. But you might be using this database provider B. This one, as you can see with the little emojis, is available everywhere, but it works slightly differently on tvOS and on Linux. Maybe you have some kind of different API calls or something like this. So in this case, you will be able to reuse your model, but not on all the platform. You'll have to make some little tweaks for it to work. And worst case scenario, you might be using that database provider C that gives you a database that is available on macOS, but that isn't available on the other platform. And in this case, your model layer won't be reusable on the other platform. So this shows us something that we forget quite often with MVC. With vanilla traditional MVC, we often think only of those three layers, the model, the view, and the controller. But in fact, there is a fourth implicit layer, which is your persistence. And if you make your model know your persistence, your model is not tightly coupled to your persistence, and it will be reusable only where your persistence is available. So to fix this, let me introduce you to the S layer of MVC-RS, which stands for storage. So this storage layer will be simply between your persistence and your model. It will have two tasks: talking to the persistence and converting raw data from the persistence into entities of your model. First task, talking to the persistence. This is something a bit complicated because when you talk to the persistence, calls are asynchronous. They might succeed, but they might also fail. And so your storage layer will have to take all of this into account. Second task of the storage layer is to convert data. So you'll have, of course, to convert the raw data that is coming from your persistence into entities of your model. That's when you will read data to present it to the user. But you'll have to be able to do it the other way around. When you want to persist some data, you'll have to be able to convert entities of your model into raw data to send it afterwards to the persistence. And both those tasks might fail as well. Now let's have a look at some code that we might find in the storage layer. But first, I would like to remind you this quite a common pattern in Swift, the result enum. It looks a bit like an optional, but in case of a failure, we have an error associated types. We often use this when we don't want to bother with the old do, try, catch error handling, for example. And in our example, we'll be managing this car model. So what we might find in the storage layer is something like this. We might have this read method that doesn't return anything, of course, because as we know, talking to the persistence is asynchronous. So instead, it takes a closure as a parameter that will be called once the work of the storage layer is complete. This closure takes a result as a parameter because the result can fail. It can fail while you are asking data from the persistence, or it can fail while you are trying to convert that raw data into entities of your model. In this case, the incomplete closure will be called with an error. Otherwise, if everything went right, the incomplete closure will be called with the appropriate array of cars. In a real-world example, we might find other read methods, such as one that will take an ID, for example, and return a single entity of your model. We might find also another read method that takes some parameters for cases when you don't want to load all the entities of your model. You might want only the cars of a given brand or something like this. So this is an example of the reading method. Let's have a look on the writing method, like this, to have a complete crude example. So those writing methods, the create, the update, and the delete, have the same signature. They will take an entity of your model and an incomplete closure that will be called once the storage layer jobs is complete. So once again, it takes an error, an optional error as parameter, because it might fail. It might fail while you're trying to convert your model entity into raw data, or while you're trying to send that raw data into your persistence. In this case, the incomplete closure will be called with the appropriate error. But if everything went right, the incomplete closure will be called with nil. So now that we have this storage layer, our model layer still modelizes a domain, but that's all. It's no longer tied to your persistence, and now your model is truly reusable on all the platforms where Swift is available. Your storage layer, alongside the model, is also reusable, but this time only on the platforms where the same persistence is available. I would like to come back to this piece of code. To write this as a protocol is a good idea because like this, you can easily write different implementation. You can have a storage layer for a SQLite database, for a Couchbase database, or for some REST API calls. And thanks to this, you can very easily switch your persistence. So here you might tell me, okay, but I don't change my persistence every week. And I hope you don't. But it might be useful for other use cases as well. If you want to test, or if you want to mock your persistence, you can really easily implement a mocking storage as well. So this new layer, the S layer, storage layer, gives us a very simple model that will be reusable on all the platforms, and it allows us to change very easily the persistence of our app. I'd like to come back to the regular vanilla MVC. What allows MVC? MVC allows to answer a number of use cases. Those use cases might be, show me a list of cars, show me a detailed view for this car, update this car, delete this car. But what MVC doesn't tell us is on which use case those our app starts, nor does it tell us how do we transition from one use case to another one. So what we usually do is something like this. Here we are in the controller layer. We are in this cars list controller. This guy should be only responsible to render a list of cars. But what we do often is, in the didSelector@indexPath method, we will instantiate the next controller, in this case, the car details controller, and we will push it on the navigation stack. There is two things ugly here. The first one is that we are pushing something on the navigation stack, but we shouldn't be aware that there is a navigation stack. Once again, we are in the cars list controller. Its job should be only to render a list of cars. It shouldn't be aware of what's above him. Second problem is that the cars list controller is choosing what is going to happen after him by telling that it will be a car details controller. Same kind of problem. It should be only responsible of rendering its list of cars. It shouldn't know what is going to happen after him. And this will go bad if your app grows. Imagine, for example, depending on the user of your app, you will show different screens. You may have some kind of admin user, and for them, when they touch a car, they will have a form view so they can update the car, and regular users still see a detailed view. And now, all of a sudden, your cars list controller, whose once again only job is to render a car, is now aware of your user and what your user can or can't do. So that's a problem. Another problem we see often with regular MVC is the lack of dependency injection in the controller layer. We don't often see this kind of signature, for example. Usually, for a cars list controller, again, same example, we will have more something like this. We will initialize it with nothing, and in the view did load, the cars list controller will ask the persistent through the model to get the data it needs to be rendered. That makes sense in a way, because if that guy is not asking for the data it needs, who is going to give it the data it needs, right? But the problem when we do this is that now, this cars list controller, this poor guy, has to manage different states. Asking the persistence, we saw it, is something asynchronous, so it will have to manage a loading state. We saw also that it might fail, so it has to manage an error state. If it didn't fail, the return can be empty, and it will have to manage an empty state. And finally, it can do the job it was intended to do. So controllers knows way too much things. They know who is above, who is after. They have to manage different states, and that's why we often get the famous, or rather infamous, massive view controller issue. So to help us with that, I would like to introduce you to the R layer of MVC-RS, which stands for router. The router is something that will be above. It will know your storage, your model, and your controller. And the router will have three tasks: the communication with the storage, the coordination of the controllers, and the management of the Chrome. The communication with the storage means that it's only the router that will talk to the persistence through the storage. Your controller layer won't ever ask for data. That will be always the router that will give data to the controller. And so we will be using dependency injection in the controller. Second task, the coordination of the controllers. I choose the coordinates verb here on purpose because it's really closely related to the coordinator pattern you might have heard about. It was introduced by Sarush Kanlu in his talk at NS Spain 2015. If you haven't seen that talk, I highly recommend it, even if it's written in a strange old language. And the last task of the router is the management of the Chrome. So the Chrome is everything that is outside of your controller. In iOS development, typically, it's the navigation bar and the tab bar. So let's start with talking to the persistence. So the router, when we want to display a list of cars, for example, we will have a code snippet a bit like this. The router knows that to display that list of cars, it needs to ask data to the storage, and that takes some time. So it will start by showing a loading screen. Then it will ask the storage for data, and once it will receive a response, if it failed, it will show an error screen, and otherwise it will test if the cars array is empty. In this case, it will show an empty screen. Otherwise, it will instantiate the cars list controller with the appropriate data, and it will show it. And so now, it is dependency injection all the way for our controller layer. The router will always give the data the controllers need. Second task of the router layer, the coordination of the controllers. So we saw previously this example. We won't write something like this any longer. Instead, we will write rather something like this. And in the did select row at index path, we will call this car touched closure, and that's the router will set this property to tell what is going to happen once the user has touched a car. So let's go back to the router layer here. The router instantiates a car list controller with the data it gets from the persistence, and it can set the car touched closure by saying, okay, after you, it will be a car details controller. And if we have the same example as before, our app grows and does more things now, and once again, depending on the role of the user, we will show a car details or a car form. This time it's okay. This time it's totally fine. When we were doing this in the controller, it was a problem because the car list controller shouldn't be aware of your user. But in the router, it's okay because the router has to know everything that might impact the transition between your different controllers, the transition between your different use cases. Last task of the router is the management of the Chrome. Once again, this bad example. Here, one of the problems here is that in the controller, we are talking to the navigation controller above us without even knowing if it exists. When we write something like this, when we try to set a navigation button from a controller, we are doing exactly the same kind of mistake. That controller shouldn't be aware of if there is something above him, if there is a navigation controller above him. But in the router, it's fine to do this. Look at this show method we've seen a couple of times already. This show method could be very simply something like this, simply pushing on the navigation controller. And the router will have a navigation controller as a property. So from the router, we know that there is a navigation controller, and we know that we will display our controller into a navigation controller. So here, it is fine to set a navigation bar button for our controller. It is the same kind of idea if you want to set a tab bar item as well. So I would like now to show you quickly some code we might find in the router layer. We might start by writing a router protocol that will present those convenient methods we've seen already, show loading, show empty, show error. Maybe we will implement some of those in an extension. And for a concrete usage of this router, to stay in the car example, we will have a car router that will have a navigation controller and that will expose some different methods to show different screens available. So obviously a show cars list, which will be the method we saw previously. We might also find a show car details method to show a detailed view of the car. But this show car details method already takes some data. We might also want to be able to render a detailed view of a car without having the data already. If we implement some deep linking, for example, we might want to have some kind of links that directly launches a detailed view for a car. In this case, we would write another show car details method, but this time that would take an ID as a parameter, and that will be responsible to ask the storage for the data, and once it gets the appropriate data, it will call the show car details that's above. So to conclude, the advantages of that pattern. First, it's an MVC-based pattern. So most of the core concepts are well known by most of developers. It also means that it's pretty easy to convert an existing MVC project into an MVC-RS one. We are now able to reuse our models everywhere on all the platforms, Linux and so on, so that's pretty interesting. We can easily change our persistence. We now have, and that's one of the most interesting points, some very light and very dumb controllers. And we love controllers to be the dumbest possible. So with this pattern, you won't ever see again some massive view controller issues. It is easily testable. And when I say testable, it's not only from a unit testing point of view. It's also for your day-to-day job. When you're working on a new feature or when you're trying to fix a bug or something like this, you often have to run your simulator and to go through 1, 2, 3, 4 screens before arriving to the part of your app you are working on. With the router, you can choose very easily where the app starts, so you won't lose time like this. And it is also very easy to implement some deep linking. You'll just have to write a little method that will map some URLs to the methods of your router. That's it. Thank you.
Thanks so much. I like the idea. It's pretty cool. Did you consider using a view model also as a plus? Like,
not really. Not really, because you have already all the span and all the possibilities of what you need from really reading the data and having something really decoupled and that makes only the job of reading the data and converting it to some data you can exploit, and then the router that will pass it to the controller. So you don't really need that extra layer of a view model to help us somewhere there.
I have another question. All right, in the front.
Hi. I agree with most of everything you've said, and we've actually been using closures for stuff like the select item, row items path, and stuff like that for a while. But the problem we've been facing is that when controllers, or when it gets very complicated, and then you have a lot of closures, and then you have a bug, and then you try to find out where this code is being called, you end up staying for 2 hours trying to just find, where is this happening? When without it, it would have been very simple. You look at the did select. Oh, okay, I found. So not even where the closure is called, but where the closure is set. This is most probably the problem. Because when the closure is called, you can find it with breakpoints, but who set it, you don't really know, and Xcode doesn't help you there. So have you found a way?
There is not, no, I didn't find a way to do it better. That's a bit of the limitation when you're using closure for this kind of purpose. When it starts to grow way too much, it's maybe better to go back to the old delegate pattern rather than using 3, 4, 5, 6 closure that you sometimes have to initialize at the beginning, and you have some initializer that becomes really ugly. So there is kind of a trade. So until 2, 3, maybe 4 closures for a given controller that's manageable. After that, it's too much.
All right, we go in the back. Yeah, we have some time anyway for questions, so go ahead.
And I'm not hungry at all, so it's okay.
Go ahead. Me neither. That's also the reason why I was not even trying to get your talk before eating, which I was. But anyway, go ahead.
What about using a similar approach to the results enum for managing the closures? Like you have a one-to-one match of closure 1, closure 2. They have to have better names, of course.
Yeah.
And you set only those to that specific one, so afterwards it has a specific name, that closure, sort of.
So what do you mean? If you want to work with some kind of optional closure, or?
Yeah, instead of you could use an optional, I think.
I do. In fact, in practice, I often do this with optional closures as well. So because there is sometimes you don't want to set it. So You don't want the closure. In fact, delegates a part of the job. You have some, for example, this list controller. Its job is to render list, but there is some part of the job that you don't want it to be done. So to choose what's going to happen next, that's none of its business. So you give that responsibility back thanks to the closure. But sometimes those closure don't mean something. You may have a closure, for example, use it for the button you have when you swipe on a cell. And I set this with a closure. So the closure tells if you should have a button on the side or not. But sometimes you just don't want this, so this is an optional closure and you don't set it simply.
Yeah, what I meant was that you use an enum to group the closures you use for a certain job together.
Yeah. So that might be a point. If you follow a bit Chris Heidoff and what he's talking about in the Swift talks and some of his article, the way it goes after that, when there is too much closure, is to usually create some kind of struct conf struct, something like this, that will wrap all those closures and maybe some kind of parameters as well. So that might be also a way to go when your controller or anything goes and uses too much closures.
Okay, thanks.
Hey, cool talk.
Thank you.
Short question regarding reusing models. Have you ever actually been able to reuse models in a production backend? Because of course not strictly Swift related, but it's more of a, well,
I was talking with Jan just
question.
previously a bit about this, and he will talk about that in his talk later. For the moment, not really. It's more kind of an ideal thing we want. I want to have my code really reusable. I want to write my model only once, and I want it to run on my watch, on the mainframe server, on my computer, everywhere. But in a real world production example, for the moment, I cannot say I have achieved that yet. But I hope I will.
thank you.
All right. While the microphone is moving back, just a little organizational note. We found a lot of old Objective-C, or actually Objective-Cologne gigs. So help yourself and get one of those T-shirts. Just check it out. Some of those are girly. So if you are not a woman, be sure to pick the men's shirt. Otherwise, might look interesting. Also, yeah, the rest I will say it after the next question.
Okay, thanks for the talk. I think I missed it. Do you have only one router who manages everything, or do you have
No.
super router and sub routers?
Yeah. For this part, there is different kind of ways you can go. Usually, if the app grows, you will have different router. You may often have one of app router that will be the one that will tell where the app starts, for example, and what are the routers that will be called after that. But there is also almost two ways to do the things. You might have one router per model entity. So that's why I had a car router, and if the app grows and I manage some drivers, for example, I would have a driver router as well. But you might also write the router, and that's where the router is very closely related to the coordinators, if you've seen this. And for the coordinators, I know they pack more some kind of part of the application. So you might have some onboarding router and then a settings router or something like this that will more pack some different part of your app. So that's a bit the two kind of ways you can go. But of course, you'll have, in fact, to split this because there is lots of works, in fact, that goes in the router. And that's what I've been really enjoying with that pattern, is that it really shows you all the work you are pulling out of the controller. And when you see that, when you see the quantity of code that goes in the router, and you think that before that it was going in the controller, you think it's crazy, because there is lots of concern there. There is lots of things to do. So you'll have, when your app grows, to split those routers into different routers. And so there is two ways a bit to do that.
We have the panel tonight. Are we excited about the keynote?
Yay.
Yes? No. Are we excited about the keynote?
Yay.
All right. So we have the panel before the keynote. I prepared some themes, but you feel free to shoot some other themes. To do that, the easiest thing is tweet with the hashtag SwiftConf some themes that we want to speak during the panel. Also, if you have a very technical question or whatever, just DM it to SwiftConf or send it via email, whatever. I might do a little funny contest between the speakers. Guess what? To win objective Cologne crap. It's like a recurring theme. Besides that, for now, it's actually pretty cool. We have about an hour and a half, but I think we will enjoy this hour and a half to have lunch, to go outside, and to speak with everybody, and be back at worst case 2 p.m. please. And other than that, enjoy the food. If you have any question, ask me, and I want to meet every single one of you. All right? So that's it.